So next part, that is the relation between hydrolysis constant and degree of hydrolysis. Hydrolysis constant and degree of hydrolysis. Again, we have to write that equation, that is Ba plus H2O giving BOH plus HA. BOH plus HA. So again, the salt will be completely ionized, and also this is a strong basic solution, so this BOH will be completely ionized. So we can write it as B plus A minus plus H2O giving B plus OH minus plus HA. Okay, so again B plus will be cancelled, so A minus plus H2O giving OH minus plus HA. Therefore KH is equal to OH minus into HA divided by A minus, isn't it? So this is equation number 1. Then again we have to write the concentrations, that is at the start of the reaction. So what about the concentrations? This A minus will be at equilibrium. The concentration of A minus will be C into 1 minus alpha, and concentration of BOH will be C alpha, and concentration of HA will be C alpha, isn't it? So therefore we can substitute all these values in this equation number 1. So concentration of OH minus is C alpha into concentration of HA is C alpha divided by concentration of A minus is C into alpha. This is also just like the previous case. So it becomes C square alpha square divided by C into 1 minus alpha. 1 C got cancelled. So this becomes C alpha square divided by 1 minus alpha. Again 1 minus alpha, it is approximately equal to 1. So it will KH will be equal to C alpha square. Or what about alpha? Alpha is equal to square root of KH divided by C. Okay, alpha is equal to square root of KH divided by C. Then again you have to substitute for KH. What is KH? KH is equal to KW by KA, isn't it? So in this equation we have to substitute for KH. KH is equal to KW by KA. So alpha is equal to square root of KH divided by C. Then KH is equal to KW by KA. Therefore alpha is equal to square root of KW by KA into C. So this is the alpha. So alpha is the degree of hydrolysis. So degree of hydrolysis, it can be written by either alpha or H. Okay. So hydrolysis constant KH and alpha. Okay. Alpha is the degree of hydrolysis and KH is the hydrolysis constant. Then again the next one, that is we have to find out the H plus ion concentration, isn't it? H plus ion concentration. So here it is a strong base, isn't it? So in this equation we will be having only OH minus. So first of all you have to find out the OH minus ion concentration. Then from that we can calculate the H plus ion concentration. Okay. So what about the OH minus ion concentration? It is equal to C alpha, isn't it? So we have to start from this OH minus ion concentration, that is equal to C alpha. OH minus ion concentration is equal to C alpha. Again, what is alpha? The degree of hydrolysis, alpha is equal to square root of KW by Ka into C. That is equal to C into square root of KW by Ka into C. Okay. Then again, what about the ionic product of water KW? KW is equal to concentration of H plus into concentration of OH minus. Okay, so again H plus ion concentration. Here we have to find out from OH minus, we have to find out H plus ion concentration. So H plus ion concentration, that is equal to KW divided by OH minus. Okay, so here it becomes, what? How will you simplified. So this becomes C into Kw divided by Ka, isn't it? C means C is equal to root C into root C, isn't it? So one root C will be cancelled. So this root C will be there in the numerator. So C into Kw by Ka. Then again you have to substitute this OH minus ion concentration in this equation. So therefore that will be equal to Kw divided by what is OH? OH is equal to square root of C into Kw by Ka. Okay. Then you have to simplify this equation, that is here root Kw into root Kw. So one root Kw got cancelled. So we will be getting square root of this Ka will be going to numerator, Ka into 1 Kw divided by C, isn't it? This Ka will be going to numerator and this Kw, that is here root Kw. So one root Kw got cancelled. So this root Kw will be in the numerator divided by C. Then what is the next step? So here we got this H plus ion concentration. Then we have to convert it into the terms of pH is equal to minus log H plus, isn't it? pH is equal to minus log H plus. So first of all, for that we have to take the logarithm of this equation. So taking logs on both sides, taking logarithm on both sides, this becomes log H plus ion concentration, that is equal to the square root means it will be half into log Ka, then plus log Kw, then numerator C, that is minus log C. Okay, then what is the next step? We have to take the negatives, isn't it? So this becomes minus log H plus, that is equal to half into, that is this is minus log Ka, then minus log Kw plus log C. Okay, then this becomes pH. pH is equal to half into minus log Ka is pKa minus log Kw is pKw plus log C. So what about the resulting solution? So pH is equal to pKa plus pKw plus log C. So the resulting solution will be an alkaline solution. Okay. So this formula is also very important. You have to study this formula also. Then coming to the examples for the salt of weak acids and strong bases. That is, for example, sodium acetate CH3COONA. CH3COONA. So here the CH3COONA will be in water. It will be ionizing as CH3CO minus. Sorry, CH3CONA. It will be reacting with water to form CH3COOH plus NaOH, isn't it? So again, the salt will be completely ionized and the strong base will be completely ionized. Therefore, we can write it as CH3CO minus plus Na plus H2O, giving acetic acid, weak acid, so not completely ionized, plus sodium hydroxide, completely ionized, so Na plus OH minus. So here Na plus will be cancelled, so it becomes CH3CO minus plus H2O, giving CH3COOH plus OH minus. From this equation we can write the hydrolysis constant also. So here see the resulting solution, it has got OH minus ions in excess, isn't it? So that means the resulting solution will be an alkaline solution due to the presence of excess of OH minus. Okay, due to the presence of excess of OH minus. So this is how we are finding out the salt hydrolysis. Hope you are clear up to this. Then we can move on to the next example, that is sodium carbonate. Sodium carbonate, example 2, Na2CO3 undergoes hydrolysis, that is reacting with water to form 2NaOH plus H2CO3. So this one will be ionizing and this sodium hydroxide will be ionizing. Carbonic acid, it is a weak acid. So sodium carbonate will be ionizing as 2Na plus CO3 2 minus plus 2H2O giving 2Na plus 2OH minus plus H2CO3. Again Na plus will be cancelled, so the resulting will be CO3 2 minus plus 2H2O giving 2OH minus plus H2CO3. So here see the resulting solution also, it is having OH minus ions in excess, therefore the resulting solution is alkaline in nature due to the presence of OH minus ions. Okay, hope you are clear. Okay, then the next one, next category or the next group of salt hydrolysis, that is the hydrolysis of the salt of weak acids and weak bases. Weak acids and weak bases. So here we can consider the salt Ba plus H2O will be ionizing as BOH plus HA. So see here, both the salts are not completely dissociated, isn't it? So only the salt will be completely dissociated. Only the salt will be completely dissociated. The weak acid and weak base will not be completely dissociated. So we can write it as B plus A minus plus H2O giving BOH plus HA. Therefore, KH, hydrolysis constant KH, that is equal to concentration of BOH into concentration of HA divided by concentration of B plus into concentration of A minus. Okay, so put it as equation number 1. Then the next one, that is the next heading, that is the relation between which one? KH, KW, ionic product, then since it is a weak acid Ka, then since it is a weak base Kb. So here we have to find out a relation connecting KH, KW, Ka and Kb. Okay, so already we know Kw and KH, isn't it? KH we got here. Kw is equal to concentration of H plus into OH minus, isn't it? KH is equal to concentration of H plus into OH minus. Then what about Ka? That is weak acid. So HA will be ionizing as H plus and A minus. So Ka will be equal to concentration of H plus into concentration of A minus divided by concentration of HA. Similarly, the weak base BOH, it will be ionizing as B plus and OH minus. So Kb is equal to concentration of B plus into concentration of OH minus divided by concentration of BOH. Then again, so put it as equation 2, then equation 3. So one number is missing, I think. So this is equation 2, 3 and then 4. 2, 3 and 4. Okay. So dividing equation 2 by 3 and 4. Okay. Equation 2 divided by 3, equation 3 and 4. So that means it will be equal to Kw divided by Ka into Kb. Isn't it? Equation 2 Kw. Ka is equation 3 and Kb is equation 4. Kw by Ka into Kb, that is equal to Kw is concentration of H plus into concentration of OH minus divided by Ka Kb. Ka is this one divided by HA. So HA will be going to the numerator. Then Kb, this one B plus into OH minus divided by BOH. BOH will be going to the numerator. So this got cancelled. H plus will be cancelled. OH minus will be cancelled. So the remaining will be equal to concentration of HA into concentration of BOH divided by concentration of A minus into concentration of B plus. Okay. So what about this term? This will be equal to KH, isn't it? That is from equation 1, this term will be equal to KH. So this is equal to KH from equation 1. So what about KH? KH is equal to KW by KA into KB. Okay. KH is equal to KW by KA into KB. This is also very important. Okay, then the next one, that is regarding the relation between hydrolysis constant and degree of hydrolysis. Hydrolysis constant and degree of hydrolysis alpha or H. Again, this BA will be ionizing as B plus and A minus. I will be writing the final equation B plus plus A minus plus H2O giving BOH plus HA. So at equilibrium, what about the concentrations? It becomes C into 1 minus alpha. Here also it becomes C into 1 minus alpha. This one C alpha, this is C alpha, isn't it? That we had already discussed. Then KH is equal to concentration of BOH into concentration of HA divided by concentration of B plus into concentration of A minus. Then again concentration of BOH, C alpha into C alpha divided by C into 1 minus alpha the whole square. Isn't it? Or C into 1 minus alpha into C into 1 minus alpha. So again the C's got cancelled, isn't it? So it becomes KH is equal to alpha square divided by 1 minus alpha the whole square. Then again 1 minus alpha the whole alpha, it is approximately equal to 1. So KH is equal to alpha square, or alpha is equal to square root of KH. Alpha is equal to square root of KH. Again, what is KH? KH is equal to KW divided by KA into KB. So therefore alpha is equal to square root of KW divided by KA into KB. Alpha is equal to square root of KW by KA into KB. So this is the degree of hydrolysis. Then the next one, that is the H plus ion concentration and pH. H plus ion concentration and pH. H plus ion concentration and pH. So here HA ionizes to give H plus plus A minus, isn't it? So Ka is equal to concentration of H plus into concentration of A minus divided by concentration of HA, isn't it? So again, so from this equation we can write H plus ion concentration. So H plus ion concentration, that is equal to Ka into concentration of HA divided by A minus, isn't it? Ka into concentration of HA divided by A minus. Again, this will be equal to what is the concentration of HA? HA, it is equal to C alpha, isn't it? HA is C alpha and A minus is equal to C into 1 minus alpha. So we can substitute it. So Ka into HA is C alpha divided by A minus is C into 1 minus alpha. So C got cancelled. This 1 minus alpha, it is approximately equal to 1. So that is equal to Ka into alpha. H plus ion concentration, that is equal to Ka into alpha. Then what is alpha? Alpha is equal to square root of Kw by Ka into Kb. So there you have to substitute. So H plus ion concentration, that is equal to Ka into this formula. Ka into square root of Kw by Ka into Kb. So 1 Kb will be Ka will got cancelled. So it will be equal to Kw by Kw into Ka divided by Kb, isn't it? Kw into Ka divided by Kb. Then you have to convert it into the form of pH. Okay. So I'll be writing the equation once again. So H plus ion concentration, that is equal to H plus ion concentration, that is equal to square root of Kw by Kw into Ka divided by Kb, isn't it? Kw into Ka divided by Kb. So then minus log H plus, or first of all you have to take logarithms. Log H plus, that is equal to half into log Kw, isn't it? Log Kw plus log Ka minus log Kb, minus log Kb. Then again taking negative logarithms, it becomes minus log H plus, that is equal to half into minus log Kw minus log Ka plus log Kb. Okay, so therefore this minus log H plus is equal to pH, that is equal to minus log Kw is pKw minus log Ka is pKa plus pKa plus log Kb. Sorry, plus log Kb, plus log Kb, that is minus pKb, isn't it? Minus pKb. So pH is equal to half into pKw plus pKa minus pKb. This is plus log pKb, isn't it? So this will be minus pKb. So this is the formula for finding out the pH for the hydrolysis of the salt of weak acid and weak base. So this is about the salt hydrolysis, and now you have to go through the some of the problems here in your textbook. That it is just the formulas we can substitute in the formulas. See, calculate the hydrolytic constant and degree of hydrolysis and pH of 0.02 molar aqueous ammonium chloride solution. Kb is given. So Kb is equal to 1.85 into 10 raised to minus 5. So Kh is equal to, so here you have to calculate the hydrolytic constant, that is Kh. Kh is equal to Kw by Kb. There you can substitute directly. For Kw, you know, the value is 1 into 10 raised to minus 14, isn't it? It is understood. Then Kb is given 1.85 into 10 raised to minus 5. So then you can calculate Kh, isn't it? Then degree of hydrolysis, that is alpha. Alpha is equal to square root of Kh divided by C. So the simple substitution is all there in this. So you have to work out these problems also. It is very important. I am not doing this problem since it is very simple. You can just substitute in the formula and find out. Okay. If there is any doubt, please call me. Okay. So this ionic equilibria topic is also over. Thank you.